Alright, so we're going to go over Newton's third law, work, power, and then also friction and the law of universal gravitation. So, I know this is probably a review, but just so we've got all our notes on this page, the law of universal gravitation says that all bodies exert a gravitational attraction on all other bodies. Gravity depends on mass, and so the more mass something has, the more gravity it has. And all things have gravity. Planets are just really, really big, so they have a lot of gravity. You can see in the graph here that Earth is at the 1 mark, so anything that's below 1 has a gravity that's smaller than Earth. Anything that's above 1 has a gravity that's much bigger than Earth. The bigger planets have more gravity because they have more mass. Gravity also depends on the amount of distance between two objects. So the further away from an object you are, the less that gravity is going to affect you. And so the further away from Earth you are, the less you would weigh because of Earth's gravity. So here's a few different pictures. If you weighed 150 pounds on Earth, this is what you would weigh on some of the different planets. Alright, so next we're going to look at friction, and there are lots of different types of friction, but the main idea is that friction is something that opposes the motion of an object. So we've got a picture here that kind of shows on a very microscopic scale what happens with friction. So the force of friction acts opposite of the initial force or opposite of the motion. So we're going to look at a few different types of friction. The first one is our sliding friction, which is when there is contact between two surfaces. And you can see the picture here. We've got two different surfaces that are being pressed against each other, sliding with the friction. And air resistance is another type of friction. It's where air pushes against an object. You can see the air resistance pushing up on our skydiver on our picture here. And then we also have rolling friction, which is the friction between the tires of a bike and the road or any other type of rolling object. And one of the important things to remember is that when we're talking about friction, one of the things we want to do is changing friction. Most of the time, one of our goals is going to be to reduce friction to make things easier to move. Alright, so next we're looking at work. Work is a term that you've probably heard lots of different times, but in terms of physics and science, work is a force applied to an object over a distance, and it can be calculated as force times distance, and it's measured in something called a joule, which is the same thing as a Newton times a meter. Another word that you've probably heard lots, but is different in terms of its science or physics definition, is power. And power is our amount of work in a given time. And that's measured in something called watts, which are just going to be joules over seconds. Power is measured as work divided by time. Alright, and finally we're actually getting to Newton's third law. Newton's third law states that for every action there is an equal and opposite reaction. There are lots of different examples of Newton's third law. The picture that you have on your paper is a rocket. When all of the gases are pushed out of the bottom of a rocket and they are pushed downwards, that causes the rocket to be propelled upwards into the air. If you've ever let go of a balloon in the air after blowing it up, the same thing happens. The air rushes out one way and the balloon goes the other direction. When you jump on a trampoline, if you notice the trampoline goes down and then pushes you back up the opposite direction. So every time there is a force, there is an equal and opposite force happening at the same time. Just oftentimes you can't see or feel that opposite force happening. For your activity to show you Newton's third law in class, you're going to be using two spring scales to measure force. You're going to hook the first one to wherever your teacher tells you to, either along a sink or along one of the lab benches, and then you're going to hook a second spring scale to the first spring scale. Now remember to gently pull on the spring scales. We don't want to stretch the springs, but as you're pulling, you want to read the force on both spring scales. And then you want to pull a little bit harder on one, and then let go a little bit on one, and each time reading the force on both spring scales to see what the difference is, or if they're the same, or how they compare.